This is the third in the series of 3 videos on Introduction to Integration. In this video, we'll be looking at definite integration, and you should already know how to integrate simple functions. Now, in previous videos, we looked at integrating functions like this, 2x plus 3, and we found that it was equal to x squared plus 3x plus c, where c is an arbitrary constant. This is known as an indefinite integration. And in indefinite integration, we have the arbitrary constant c. A definite integral looks like this, and in this case you have these numbers here, 1 and 2, and these are known as the limits. 2 is the lower limit. I correct myself there, 1 is the lower limit and 2 is the upper limit. And what we do here, we integrate as before, and 2x plus 3 becomes x squared plus 3x, but we don't add the arbitrary constant. Instead, we write these square brackets, put the 1 and the 2 here, and now we substitute first of all 2 into the expression, so that would be 2 squared plus 3 times 2, and then subtract and then substitute in 1 into the expression, so that would be 1 squared plus 3 times 1, and that equals 4 plus 6, that's 10, minus 1 plus 3, which is 4, equals 6. So the integral of 2x plus 3 dx between the limits of 1 and 2 is 6. We notice that this integral, this definite integral, the solution is a number, as opposed to when we, the indefinite integration case, the solution was a function of x with the arbitrary constant c, which represents a family of curves. So quite a different thing. This is a function of x, and this is a number, a constant. So in general, a definite integral has this form, integral of a function of x between the limits of a and b. And since integration is the reverse of differentiation, if we have the integral of the derivative of a function, this integrates to f of x, and then we substitute in the limits first b, then a, to the and subtract. So the integral of the derivative of the function is the value of the function itself at b minus the value of the function at a. This is only true if the function f dash of x, the derivative, has a value, it exists in the interval x between a and b. This wouldn't be the case for this function here if we try to integrate between -1 and 1, because the integral or the function doesn't exist at x equals 0. As we can see, it goes off to infinity. This is the end of the video on definite integration. Now return to Study Smart, where you will find an exercise to practice.